G'day and welcome to my garage. I have the gingery steady rest positioned on the lathe, and this is an addendum to the build. I know when I built this thing, I was thinking or trying to look in his book, in Gingery's book, as to where to put the offset of the securing bolt here in relationship to the centre of that steady rest ring. It wasn't clear in his book, and I must have been. I think I was. My first job might have been the counter shaft for the gingery mill. So because the tool rest was working between the chuck and the steady rest, I mounted this base offset to the left, to the right, to the back. That's now, well, now it was a problem later on when I had to drill, centre drill the end of the main spindle for the mill. But I wasn't using I didn't need to use the cross slide for that job. I only had to centre drill, so the tool post was used for that, and it worked. But I realised then that I was going to have a restriction here as to tool reach. That steady rest is set up in position, just sitting there, and the carriage is moved as far to the left as it will go until it hits the base of the steady rest. The tool is still 20 mil short of reaching the end of that shaft. I can't go any. I can't bring the steady rest much further to the left, because it's actually sitting around the bearing of that shaft. So to reach the end of that shaft, it would require the tool to have a fair amount of stick out, and it's a very limited range of, oops, I just moved it. It's a very limited range of movement of the carriage from left to right. That was a stationary position, and I only get about 10 mil. What have I got? About 20 mil travel. Not much. So the dilemma. Now, before I go on with what I'm going to do about this, I might just mention the clamp down plate, bolt, and nut is here on the back. You could ask, well, why didn't I put it in the centre of the where are we? Yep, in the centre of the base block of the steady rest. Well, the problem with that is there's not much room in here to get a nut and a spanner. I can get it in there. That's not a problem, but I would have very limited room to get a spanner onto that nut. So that's why it's offset to one side. The reason I got very limited room is because this is a mini lathe, so that this ring here is relatively small. Well, it is small. So anyhow, that's the problem I've got. So now to work on the end shaft, I need to move the base of this. Are we still on the bearing? Let's just get that out of there. Turn the base around. No, not turn the base around, turn the whole thing around, silly. Just let me get this tool out of the way. Turn the whole thing around. Mount it back in position. It won't at the present moment, because now this side, this is the opposite side of that block being turned around. There's no 45 degree on the edge of this block along there. So what I need to do now, you can see that the mounting bolt on the hole is over the back. Now it's the same in relationship of the ring to the mounting base. It's the same as it was before. The whole thing's just now turned 180 degrees. So I need to machine, excuse me, I need to machine a 45 chamfer on that to sit on this raised section. I take the plate. I'll take the plate off this side and mount it to the other side, because the plate is the second half of that 90 degree included angle. So that plate gets flipped around, cut a 45 on this side, and the plate's then mounted to this side. So yeah, depending on which way I need it, I just take the plate off one side and put it onto the other side, and that allows me then to position this as it's supposed to be. And, oops, it's not bolted up, obviously. That's better. That will now sit there, and I've got plenty of room to get in and machine the end of that shaft. And I would have about 75 mil travel. I don't have a ruler handy, but I would have about 75 mil of travel, 3 inches of travel. So that's the job. Machine a 45 on this face, and take the plate from the other side and mount it to this side. So let's go and do that. And just in case, if you're wondering, why don't I just turn, rather than turn the block around, leave the block and turn the ring main body around. If I line up with the original holes from the base block into the main body, I then lose the mounting hole. It's underneath there. Now I could put new holes into the main body at a position where I can still access the mounting bolt. I could do that, but the advantage I would get is about 35 millimeters in more travel. of the cross slide. Now that's not bad. That'll bring it to there. Let's put a tool in there. That'll bring it to about there. So yeah, I can work the last 25-30 millimeters of the shaft, but it's not much gain. Not much gain at all. I know I can traverse the cross slide. I can traverse that further, but it's already sticking out a bit, about 20%. What do I get out of that? About 60 mil, I think. I could probably go about another 40. No, another 30 maybe. I might get 30 out of it. But if I have to, I would still have to drill new holes here. Okay, that's only 2 holes compared to 2 holes and machining the 45 if I turn the base block around back to where it was originally. No, I'll go back to my original and machine that base block 45 degrees on the other side and remount this plate. The only disadvantage of machining the other side is that will tip because it's sitting on the outside edge. There's clearance on this side. It doesn't sit on the bed. It doesn't sit on the bed on this side. It sits on that raised section. Whereas this side is sitting on the outside edge. But that doesn't matter because it doesn't have to be 100% concentric with the job. It's 3 individual arms that can be easily put off centre. Now, back to machining and drilling 2 extra holes. Alright, got to think about getting started on this. I'm machining off the other side of the base block, the mounting block for the steady rest. So it's got to look the same as that. I'm taking a 30th hour cut at the moment.